same. So you're okay with the examples of proportions and testing hypotheses by using, you're okay with the requirements, right? I showed you where those were. Number 3 was the first one that has a real kind of twist in there. That one's a little bit twisted. A lot of the other ones are pretty straightforward, but that one has a twist in it. Did you see the solution that I posted?
I'm looking for it.
If not, I think she might. I know she said she sent something out, but I get the Canvas messages. I don't get the email usually. So I don't know if she sent it as an email or but what I will do, let me make sure the
No, I
captions
didn't. I don't have number 3.
you haven't seen it. Okay, then yeah, we'll go over it for sure. I have the whiteboard from it, so I will show you that because there is I think that I purposely kept that one out because I didn't know if her solution had been fixed or not. But the key, if you, because I know you like to review the bottom of the page, and the key, the last time I saw it, the key was wrong for that. So I thought she had sent out, she probably did, but I haven't seen it. She was teaching all day today, so she probably just got home a while ago. Let me do something else here while I have you, because that would be something we should address. If you don't have it, we should address that one. Let me whiteboard. So let me get the documents from that. And let me find, oh, actually, you know what? Here it is. I can download it from here. This is the whiteboard for that. Let me just download the whiteboard instead. Okay, so here, and like I said, I think I have to make sure that it rendered properly because I uploaded several videos and I'm not sure if that one was rendered properly. So I'll have to look at it. But let's look at the problem first, because this one is tricky. It says in 2009, 45.6% of motor vehicle accidents involved no improper driving. No improper driving. In an area comprised of 6 adjoining counties, it was found that out of 110 randomly selected accidents, 60 involved improper driving in some way. Okay, so notice those are different groups of people. Okay, so that percentage at the top, everybody drove the way they should have. And in the sample, you have 60 of the people out of the 110 were driving wrong, basically. At the 0.10 level of significance, is there sufficient evidence to conclude that the proportion of accidents involving improper driving differs from the 2009 proportion? So the first thing to notice is that these groups are not the same group. So here, when I did it, let me show you what happened here. So the first thing that happens is that instead of talking about that 0.456, because remember that 0.456 is the percentage of people who, so I'll put it up here just as a note. the percentage of people who were driving improperly is this was 0.456 is what you were given, right?
Mm-hmm.
But you want the complement of this, okay? Because you want the people who drove improper. So the thing is, you have to go 1 minus 0.456. And if you do that math, or you can do 100 minus 45.6, either way, you're going to get 0.544. And that's what you're going to be working with, is that 0.544, okay? Those are going to be your percentage for your null and your alternative hypothesis, okay?
Mm-hmm.
So your P is 0.544 here, okay?
And it equals or not equals and P equals or not equals to 0.544.
Correct. And if you want the top portion of this, where I do, before I come back to that, let me, if you wanted the top portion, you would do parameter would be population proportion P, because remember, now we're dealing with proportions, right? And then you would do the claim, which you already have there, but I'll write it again. Claim is H1, and its P is not equal to 0.544, okay? And then you have, of course, it's a two-tailed task. So now it's, so we have that's the claim. And then we're doing the traditional approach, or the traditional method, right? And then you go into your 5 steps after that. Remember, there is no flow chart for proportions, because we only have one test that we do for that, okay? So no need for a flow chart here, okay? Once you get past step 1, we need to find the critical values, okay? Alpha here is 0.10. So if you wanted to put, that's the other thing, if you wanted to put your givens in here, let me do that. I forgot to show that. So your givens here are going to be, if you want to put it in this step, your given information is going to be, P is going to equal 0.544. Now, they've done something interesting here, and they've given you P hat, which is your sample proportion, but they've given it to you as X. X is 60, N is 110. So they've given you the X and the N, which is, they normally won't give you a proportion and both of these, but they did that. And then your alpha region is 0.10. So alpha is 0.10 here. And if you want to calculate P hat, you can do so now. I think I waited until step 2 to do that, but this is your given information here. So now let's do our critical values. This is going to be the inverse norm of 1 minus alpha over 2. And remember, because we're symmetric. This is the Z distribution, right? We're symmetric, so we can, you don't have to put in both separately. You could, but you don't have to. I used the right side here. So I did inverse norm of 1 minus alpha divided by 2, which is 1 minus 0.10 divided by 2. And Z was equal to negative 1.64, or Z equals positive 1.64. If you took your Z-score to more decimal places, that's fine. You'll get negative 1.645 or 6454. However far you took it, that's okay. And then your formula for the proportion, which I'll remind you of. I'll write it at the top here because it's the first time we've used it in a minute. This is Z is equal to, this is P hat minus P over the square root. Should look familiar to you. This is PQ over N. PQ divided by N. Which, for the sake of space, I'm just going to write this way. Your P hat was, remember that X and that N. So P hat here was equal to 60 out of 110. And that's where we got, whoops. And that's where we got, I have no clue.
Is this
what I
one for
was
step
trying
3?
to, huh? What was
Is this
that?
for step 3?
This is for step 3. I put it in with the givens as well, but if you forgot to compute it, you can compute it here when you do the formula. That's fine. 60 over 110. I don't know, that looks more like a birthday cake than a fraction. Let me see if I can.
Yeah, it looks hard to make out.
I agree with that. Let me see if I can clean that up and make that look a little more presentable. So this is 60 over 110. I think that looks better, right? And if you work the decimal out, then that's going to give you 0.5455. This comes out to 0.5455. 0.544 came from the complement of the percentage that was given. That comes from our HO, remember?
Mm-hmm.
And then we have the square root of P, which is 0.544. Then you want the complement of that. So that's 1 minus 0.544 over 110, all under the square root. Okay.
Okay, and then square root all that.
Square root all that.
Okay.
And when I did that on my calculator, I got 0.0316. So let me know if you need to see that or not. Let me know if you agree with me.
I got a different.
Got a different answer? Okay, let me
Yeah.
see if I can, let me write it out and see if I do it and see if I got something else. 0.5455, I'll check that number too. Let's see, what is that? 0.544. And then the bottom is 0.544 times 1 minus 0.544 over 110. Okay, let's put it on the calculator and see what we got here. All right, so now let's clear this out. We put the top. So let me check first the fraction, which was 60 out of 110. So let me put that up here. 60 out of 110. Okay, that looks right. 0.5455. That looks okay. So the top part of this is going to be 0.5455 minus 0.544 close divided by square root. There it is. And under the square root, I want 0.544 times 1 minus 0.544 close parent divided by 110.
So I was supposed to put the go back to the beginning of the calculator.
The very top, you mean?
Yes.
Right here?
Yeah, that's what I forgot.
Yeah, the entire numerator needs to go in parentheses because you need to have that whole product to be divided. Let me see what I get. Let me see if I get the same thing as I got. So that's 0.032. I don't remember how many places I did I think I took it to 4 here. Yeah, I took it to 4. But if you take it to 3, if you take it to 2, you should have 0.03. If you take it to 4, you have 0.0316. But it's not going to make a huge difference in the calc, and it's not going to make a difference
Yeah, now I got it.
for the result. Okay, so then we do our step 4, reject or do not reject HO. And here, you just want to show where your critical values are. Critical values are at negative 1.64 and 1.64 positive. 0.03 is really close to the middle. I didn't show that on here as far as a number because I didn't want to clutter this with another number. So I drew a line and extended it. That's one of my favorite tricks. Draw a line and extend it so you don't have to cram. But you can see that 0.0316 is not in the tails, it's in the body. And I just wrote do not reject in the middle. You don't have to do that. But I wanted to remind you guys that that's part of the non-rejection region. And so I do not reject the null. And one thing that I forgot to do on this whiteboard is to underline. There is not enough evidence to support, because the claim is H1, there is not enough evidence to support the claim. Okay. That's number 3. There's not enough evidence to support the claim.
Mm-hmm.
All right.
Yep.
All right. That was it for that one. What else did you have a question about?
Let me check because I want to do the ones that are not on the email you sent me.
That works. That works.
Mm, very- Okay, so we already got 7. 4.
Number 4, you have a question about?
No, number 4 is on the email you sent me.
Got it. Okay.
9. I say 8.
Number 8, sure. Oh yeah, this is one that we always, sometimes for those of you who are in class watching this, sometimes she does this one in class as an example or a variation of it, because students always have questions about this one that have more to do with reading the problem than doing the calculation, but it's a good one to do. It says researchers suspect that 18% of all high school students smoke at least 1 pack of cigarettes a day. At Wilson High School, a randomly selected sample of 300 students found that 50 students smoked at least 1 pack of cigarettes a day. At alpha equals 0.05, test the claim that less than 18% of all high school students smoke at least 1 pack of cigarettes a day. Use the p-value method. Okay. Now, the first question that I'm going to ask you reading that is, what do you think the claim is?
Claim. Claim. Oh, the claim that is less than 18%.
Very good. Less than 18%. Very good, Jason. Congratulations.
Mhm.
Sometimes students find this tricky, and instead of using the 18 like you did, and you should, they focus on this at least 1 pack of cigarettes.
Mhm.
And what they get is, we get a lot of HO is P is less than 1. Remember that for the sake of this section and for the sake of your claim, you're testing a proportion here, and that should be a percentage, okay? This is talking about a behavior that this 18% of students have. This could be 18% of high school students drink beer on the weekend, or 18% of high school students go out with their girlfriends every Saturday. Whatever this is, this 1 pack of cigarettes, this is something they do. It's not a percentage that we're testing. We're testing this 18. So well done. Good job. So that means that Now, keep in mind, our claim here is less than 18%. So now, when I go to do this, I have, let me put up another whiteboard here. This is number 8. So let's start the way we start, the way we're used to. So number 8 says that our parameter is the population proportion P. Okay. Population proportion P, we know that. We know what our claim is. We just went over that. So our claim is less than 18%, which means it's H1. P is less than 18% here. And we're going to be doing the test in a minute. And we're also going to be doing the p-value approach. So this is a good one for that reason, because I haven't shown you guys a problem using the p-value approach, but we're doing the p-value. And if you want to do your givens, we can do that here. Okay. So my P, I know, is 0.18. My Q is 1 minus P. So my Q is equal to 1 minus P. And that is equal to 1 minus 0.18, right? So if I do 1 minus 0.18, what do I get?
0.82.
Right, that's 0.82. So this is 0.82. Okay. Now, what else? Did they tell us anything else? Let's take a look. I should. Okay, yeah. It says a random sample of 300 students. Remember, when they tell you sample of and there's a number, that's how big your sample was. Okay, sample of blank, sample of some number blank is your N. Okay, so N is 300 and 50 of them smoked 1 pack of cigarettes, at least 1 pack of cigarettes a day. Okay, so what we have here is we have X. So they've given me X. X is 50. And N is 300. And alpha is 0.05. Okay. Pretty straightforward, I think. Not too strange. Okay. Step 1. We're gonna write our null and our alternative hypotheses. Okay, so remember, step 1 is the same regardless of which approach we use. So HO, P. Now, if our claim is less than, then our null is going to be greater than or equal to. Good. Because our null always contains equal. And we're going to use 0.18 here. Okay. And then we're going to say you can use write your statistical equivalent for the sake of the textbook, remember. So we're going to use our little arrow here. And we're going to write our statistical equivalent, my lovely arrow. This is going to be HOP equals 0.18 or 0.18, either way. So there's my, now we're going to write my claim, which we have from the top. So P less than 0.18. Okay. And that's going to be left tail test. This is a left-tailed test. And we also know that this is the claim that I'm testing. So I'm going to move this over and write the word claim next to it. Claim here. All right. Any questions about this part so far?
Oh, no.
Looks pretty straightforward, right?
Yeah.
Remember that when we're doing the p-value approach, this is the one that might trip you up if you've been doing a lot of traditional method. When we do the p-value approach, 2 and 3 are switched. So we don't do the critical value, and we can't get the p-value without the test statistics. So step 2 is to actually compute your test statistic, okay? Which is step 3 when we're doing the traditional approach. So we need to do some calculations here, figure out what your, you have your givens. So calculate your p hat first, p hat. So let me draw, always a dangerous proposition, but let me, p hat, there we go. And remember, this is equal to x over n. So I'm gonna write this out as my values. This is going to be 50 over 300. So this is, I should probably put it down below. P hat. Let me do this. So go ahead and compute that for me, and then we'll go ahead and do some. So P hat is equal to 50 over 300. Right?
Mm-hmm.
And then we're going to take that decimal and use it in our formula. The p hat we only use one time. So let me do a little bit of a switcheroo here with the calculator. Okay, so we have 50. This is 50 out of 300. And that comes out to 0.1667. So we're going to have, this is equal to, this is equal to 0.1667. So text is going to be 0.1667. Remember, this is not the test statistic. This is your sample proportion. Your test statistic is the one that goes Z is equal to P hat minus P, right? Over the square root of PQ divided by N. Also, don't confuse your P's. That's really easy to do in this formula. And it can be hard to undo that. So be a little careful there. So what our formula will look like, there's our, what our formula looks like here is going to be, try and make it a little big for myself so I can have room to type in there. Okay, so let me, I made it a little bigger than I intended. That's all right. Let's put in room for the numerator, shall we? P hat is what I just calculated, 0.1667. 667. Your P comes from your null hypothesis, so that is 0.18. Your P under the radical, that P also comes from your null hypothesis. So this is 0.18. And Q is the complement, which we figured out up there. So you can either write it as 1 minus 0.18, or you can actually, if you figured it out like Jason has, then you can go ahead and just put in the result of that. 0.18 times, if you want to put in 1 minus 0.18, you can, but we figured it out. It's 0.82. And then you're dividing it by n, which, to remind you, is 300. Questions about this part?
No.
Okay, now another tricky part for some people, putting it in the calculator. This can be tricky the first few times you do it, so worth checking into. Also worth checking in to make sure you've got the formula correct. Now, at this point, you're going to, let me bring up the calculator so I can show you. So this is going to be, clear the calculator, move this out of the way. So now, remember, open parenthesis at the top, 0.1667 minus 0.18, okay, divided by the square root of, and this becomes 0.18. If you're using 1 minus the complement, you'd put parenthesis. We figured it out, so I'm just going to use the times sign and 0.82 and divide that by 300 so that I get that. Okay.
Mm-hmm.
And then that gives me a negative. And remember, this is my z-score, so that's okay. This is a negative 0.5996. Negative 0.5996. If you round to 2 places, you would round this to negative 0.60 and call it good for that. So
So negative 0.60.
you can use that, sure. So this is going to be a negative 0.60 here.
I got a question. For step 3, it's always two, it's the 2 numbers.
Step 3 in this situation is going to be getting the p-value. We don't have a critical value here. We have a p-value. We have the area, remember?
Mm-hmm.
So we don't have a critical. We have an area under the curve here. So this is going to be a negative 0.60. And what we're looking for is, it doesn't require a graph. We don't require a graph when you're using the p-value approach. And the reason for that is that you're computing an area under the curve, and she gave you instructions for that in the handout with p-values and critical values. But just to show you what you're looking at, for those of you who might want a picture of this, remember, we know from H1 that this is a left tail test. So what we're looking at is we've got a distribution over here, okay? And we've got our z-score, which is something like this. Here's our z. And So we've got an area to the left of that. V here is negative 0.60, right? And we want to know if this area, let me shade it in red. We want to know if this area here is bigger than my alpha. Remember, my alpha here was, I believe, 0.05. Yes, alpha was 0.05. If this region alpha is bigger than 0.05, then RZ is close enough to the mean to keep the null, or to the proportion, I should say, to keep the null hypothesis. That's what that tells us, okay?
Okay.
So we've got our Z, we're gonna get our p-value. And if you need help with the p-values, remember there's the handout and there's the Canvas page on it. The p-values, the critical values for but we're looking for the p-value. It's a left tail test. So the p-value here is going to be inverse norm of negative infinity, negative E99. I'll write it, I'll move it over a little bit so we can see E99 to RZ, which is negative 0.60 and 0 and 1. Remember that because this is a left tail, we don't double it. We're only in one of the tails and we're looking for the area. So we don't need to double this one. And some of your calculators may default and place this in there for you. If you have an older 83, you may not have those last two numbers, but most of them anymore, I think, default to all four. So you should see something that looks like this, and I'm just trying to find a place that is not, okay, there. Where, oops, that was not what I wanted to do. Let me undo it. And I'll redo it up here, I think. Let me redo it over here so that, well, that didn't work out the way I intended, folks. Let me, hold on. Let me write it over here. Okay, so our p-value is inverse norm of negative E99 0.60 and negative 0.6001. And I haven't computed that, but can you tell me what you get when you do that, Jason? And I'll verify when I'm done here.
Inverse norm.
Inverse norm, negative E99, 0.60, negative 0.60, sorry, 0 and 1. So then, let's see if we agree on our results. So this is a good review. Second distribution.
When you mean E99, do you mean negative infinity minus?
Negative, It's negative because it's on the left. So second distribution, normal CDF. So it's inverse norm, as you said. And it's gonna be, this is gonna be for my area. I'm sorry, I think I told you inverse norm and I should have said normal. I misspoke. That's why you were confused, because I made an error there. I'll fix that. Yes, you're right. It should be normal. That's why you were questioning it. It's normal CDF. That was my mistake. Hold on, second distribution, because now my calculator is having a moment. Normal CDF. Sorry about that, folks. Lower is negative E99. Upper is your Z-score, which is negative, whoops. Be sure you use the toggle minus down here by the enter key, negative 0.60, 0 and 1, and paste it. So it should look like this on your screen. Okay. Because we're finding the area under the curve. That area should be positive. It's 0.2743 if you round. So now, this is our p-value then, is 0.2743. So let me fix this part, because let me go and fix it here. My p-value is normal CDF. So this is p-value is equal to,
Oh yeah. Also, I know we're out of time, but I found another question that wasn't on the email.
okay, we can, I have a minute. I think we can, negative E99, negative 0.60, and 0 and 1. So I think we can squeeze it in for the benefit of our, if I don't take too much time. Let me see. I have, oh yeah, we should, we'll see how we do. So we're just about done here. 0 and 1, right? And this is going to be, as we said, this is equal to 0.2743. Now, what is our relation? This is where we do something different. So this is going to give us a little bit of a chance to practice. Step 4, we reject or do not reject the null.
For normal CDF, I got 0.
Really?
Yeah, I don't know
Negative
why.
E99
Mm-hmm.
to negative 0.60.
Yeah, for the upper,
Mm-hmm.
it just comes out as 0 on my calculator.
0 and 1. Are you sure you're using CDF?
Yes.
Okay. Check your negatives. Make sure they're actually the toggle minuses. So make sure that you actually have
Yeah, they are the toggle minus.
the little minus. Okay. Make sure you have the commas. Do you have the commas?
Yes.
And you're getting 0. That's odd. That's really odd. Can you take a picture and send it to my email, Jason?
Okay.
I don't know what, yeah, I don't know what to tell you. Can't figure out what that could be.
Or how about a video? Because,
That works.
all right.
That works too. Video or picture or something. Let me pause the recording here. Okay, so picking up from where we were, we have our p-value is 0.2. This is number 8 still. 0.2747 is our p-value. Step 4, we're going to reject or not reject the null hypothesis. So step 4, we're going to put in a box, and I'm going to move it over here just because I don't want to clutter things up too much. So step 4 here, it's going to be reject or do not reject HO. And if we remember correctly, we have a p-value of, let's go back. We have our p-value was 0.2747. So our p-value here was and our alpha was 0.05. Remember, alpha always comes from the problem. So the question that we ask is we compare our p-value to alpha. And what can we say? Is our p-value larger or smaller than our alpha here?
The p-value is larger.
The p-value is larger. What does that mean?
It's greater than.
Okay, and what does that mean for our null hypothesis?
Reject.
When it's larger, we do not reject. If the p-value is low, the HO must go. That's how that works. If it's lower than alpha, we reject it. If it's higher, we don't. So here, we're gonna, p-value is larger than alpha, we do not reject HO. Okay, we do not reject it. So we don't reject HO. And for step 5, remember, my claim, let's go back to our friend on the first whiteboard of this. My claim was H1, right? So if my claim is H1, then what I'm going to say is that I really don't need more whiteboards in my life. But besides that, I'm going to say that for step 5, I'm going to say that I have my claim. I'm just writing this as a little note. You don't have to write this, but it might help you if you're looking at the flow chart. The claim is H1, and my decision in step 4 was to do not reject HO. So do not reject HO. I know some of you that I was in class with last week had some issues with understanding the nuance of this. My decision is always about what to do with HO, whether HO is the claim or not. If I've not rejected HO, I've held on to HO. So therefore, there's no way that I can support the claim here because I'm still holding on to HO. So here, this would be, remember, when your claim is H1, you use the word support. So there is not enough evidence to support the claim. There's not enough evidence to support the claim that the proportion of students who are in high school smoke less than 1 pack a day. So we can't support that. Okay.
Mm-hmm.
Remember to underline is not and support. Okay. Hope that helps a little bit for those of you folks watching. We're going to do one more problem before I leave you this evening. So let's feel free to pause the video here if you need to clarify. Okay.
Mm-hmm.
All right. And the next one you asked for, Jason, was number 6, right?
Yep.
Let's take a look at that quickly before we look at what's going on here. Let me find the homework. Here it is. Okay. Number 6. What's going on with that one? Here it is. The largest group of moviegoers by age is the 40 to 59-year-old age group. This group constitutes 32% of the movie-going population. Okay. A theater complex randomly surveyed the customers over a 3-week period and found that out of, now remember here, because some of you have a hard time finding in, so out of that right, of 423, that's your N. That's your sample size. We surveyed 423 people. 170 fit this age group, okay? At the 1% level, does this differ from the stated proportion? Okay, nothing too weird here, okay? We don't have any weird group changes or anything like that. Don't be thrown off by this 40 to 59. That's how old they are. That describes that group. So because we don't have a stated method in here, we're using the traditional approach, okay? And our proportion is 32%, okay? So we're gonna look at our whiteboard here. And we're gonna do what we always do, which is our parameter. Okay, this is number 6 on our paper, first of all. And we're gonna write parameter. And we're gonna say it's population proportion P. Remember, there's only 4 possible answers to what the parameter is. There's never only one answer, but there's 4 possible answers right now. Mean, proportion, variance if you're working in 8.5, and standard deviation if you're in 8.5. Okay, so when we ask you what the parameter is, it's one of those 4. All right, now the claim says we're testing whether it differs, meaning it's not equal to 32. So this is not equal to 32%. So this is not equal to 32. And this makes this H1. So I'm gonna have to sneak this in there. I'm gonna sneak it in at the top just because I like to know which one it is. H1P is not equal to 0.32, and this is the traditional approach. Okay, now our givens are pretty straightforward. P is 0.32. If you prefer to find your Q now, you're welcome to do so. Q is the complement of P, so it's 1 minus P. If you prefer to write 1 minus P in your formula, that's also acceptable. But you do need Q, so it's a little handy to have it. 1 minus 0.32 is going to give you 0.68. Jason, are you there? So for those of you who may be watching, I'm going to go ahead and complete this. For the sake of those of you who are watching this is 0.68. And then you're going to have, we're going to have our N and our X. So let's go back to our, let's go back to our work here. We have 423 and we have 170 people and alpha is 0.01. So we have X is 170 and it's 423 people. Okay. If you want P hat, you can get P hat down here. Let me go ahead and compute that indirectly. P hat is going to be 170 over 423. And if I do that calculation, then I will get, let me go to the calculator here. We have 170 out of 423 people gives me 0.401 0.4019 is
Sorry.
my P hat. Hi, Jason. Welcome back.
Yeah. Did you get my email?
No, let me check.
Okay.
Hold on. Give me a
Because
moment. Stop sharing. You were saying. All right, so resuming from where we were, the givens are P equals 0.32. Q is 1 minus P, which is the complement, which is 0.68. And we were computing the sample proportion, which is P hat 170 over 423. So I'm going to go right now and share that on my calculator here. This is 170 over 423. And if I take this to 4 places, I have 0.4019. 4019. So P hat is going to equal 0.4019. And I'm going to just tuck that under here. And then 9. Okay. Now we're going to get to the actual hypothesis. Oh, and my alpha was 0.01. Okay. So my alpha is a little bit lower than I'm used to, but certainly common. Now, step one, you asked Jason if the null alternative is equal, and you're correct, it is. So this is step one here. Put it in a box. We're going to say that HO P is equal to 0.32. We don't have a statistical equivalent here because that is the equivalent. H1 is P is not equal to 0.32. This is not equal to 0.32. And in that case, remember, this is my claim because we want to know if it's different. And we also know that this is a two-tail test this time. Right. So two-tailed test. Questions about this part?
Nope.
Nope, good enough? Okay. So we've got our parts there. Number two, remember this is traditional approach. So we're computing we're finding the critical value next. We have two of them. Okay, because it's a two-tailed test. So here we're going to find our critical values, step two. And that means that since we're on a V, we're going to have our critical values are going to be Z is equal to plus or minus. This one is inverse norm. Inverse norm. 1 minus alpha divided by 2. Remember, these are going to be symmetrical. So you're going to get a positive. There's going to be a negative and a positive value here. Z is equal to it should be plus or minus. So this is plus minus inverse norm. This is 1 minus 0.10 or 0.01. Be careful there. It's 0.01 divided by 2. Okay. That, let me go to the calculator for you. We have, there's the calculator. Your calculator is your friend in this class, ladies and gentlemen. All right, so we're going to go with second distribution. Inverse norm number 3. Area is going to be 1 minus. Here we want to use the big minus. 0.01 divided by 2. Leave your mu and your sigma at their default. Paste it. I have 2.5758, which I have a negative and a positive. I'm going to round this to 2 decimal places. So negative 2.58 and positive 2.58. So my critical values here are
2.58.
positive and negative 2.58. Okay, so now my critical values are Z Ah. Typing fingers are not cooperating right now. Plus minus. Negative 2.58. And then I go to step 3 and I calculate the test statistic. So now I'm going to come over here. Step 3 is my test statistic. So I'm going to calculate that. And this is going to be p hat. So, oops, I should probably write it for you. This is p hat, which remember we calculated earlier at the top. Minus p comes from the null hypothesis over the square root of p comes from the null, the complement of the percent that comes from the null, and then divide by the sample size down here. So this becomes, let's plug some numbers into this formula and see what we get. So we have p hat, which is 0.4019 minus p, which is 0.32. Then I fix my mistake. There we go. And then I divide by the square root, and give myself some space down here, because typing is not the least real estate that I've got going on here. And I'll put a parenthesis up there too, so that we have a, oops. There we go. All right, so this is going to be 0.32. My complement here is 0.68. Remember, it's the complement of the percentage. It's in your
0.68.
no, correct. And N here is 423. So we got that, right? Let's go ahead and compute that and see what we get. So we have, whoops. Let's open a parenthesis. We have 0.4019 minus 0.32. Close parent, divide, second square root. This is 0.32 times 0.68 over 423. Questions about that so far?
Nope.
No? Okay, enter. I have 3.61 is
Same
my
here.
Z. So now we get Z. I should put Z equals for the formula. And so this is going to be Z equals 3.61. Now remember, step 4, we make the decision. And this time, since we're using the traditional approach, we do draw minimal, but we draw. And why The decimal didn't show up. I do not know. How about that? Okay, 3.61 is my z-score. Now, step 4 is my decision. So what I'm going to say is that I have reject HO or do not reject HO. And so if you remember, we have a two-tailed test here. So we've got, my drawing looks something like this. I have, oops, I can do a better drawing than that. That drawing looks like he's been staying up too late studying for final. Okay, there we go. That looks more believable. So we've got the tail area there. And remember that I've got a negative 2.58 out here. And I've got a positive 2.58 on this side. And remember, those are the regions that mark my rejection region, also called my critical region, but it's also called the rejection region. So my z-score, where is it? Well, it's over here. Whoops, it's my z-score. I don't know exactly where it is, but I do know enough to know that it's somewhere here. Let me make this black. I know that my test statistic is somewhere in this tail portion of where I just shaded. Remember, these are my critical numbers, right? So I'm in the rejection region. This is Z equals 3.61. And because of that,
Isn't the CV supposed to equal negative and positive 2.58?
yeah, they do.
Okay, because you put Z.
Yeah, but it's a Z number, right?
Oh, all right.
You could put CV there. That works.
Okay, just didn't want to get confused.
Yeah, these are Z scores. Okay. So let me, what was I doing? Oh, I know. I was gonna, because that's too far down and it's not letting me write on it. So let me see if I can sneak it up here a bit. Okay. So my Z here, this is my test statistic, right? This is my test statistic, which was 3.61. The concept here is that my test statistic falls in the critical region, right?
So do not
that's-
reject.
Well, it falls in the region. So I reject it.
Oh, okay.
Remember that another name for the critical region is the rejection region. Right.
Okay. So reject HO then?
So we reject HO, correct. So in this case, we're going to reject HO.
What?
We reject HO. There we go. We reject HO. And step 5, I'm going to put step 5 at the bottom rather than starting another whiteboard for one statement. Okay. step 5 is going to be my summary statement. Here, my claim, my claim was H1, okay? And I rejected HO. So I can say from your flow chart, I can say that there is enough evidence to, and again, the claim is H1, so my claim. There is enough evidence to support the claim. There is enough evidence to support the claim. Support because my claim is H1, and there is because I rejected HO. So I don't have HO anymore. So I'm keeping H1 in effect. I'm supporting it. So there is, don't forget to underline is. There is enough evidence to support the claim.
Okay, I got it.
Okay. And
Yep.
that, ladies and gentlemen, is all we have time for this evening. I'll see you in my next video. Jason, thank you so much for being here.
Fair
Hanging
thing.
with our technical difficulties